If we were to finish them today, would that be 10% off or 20% off?
Okay, let's have a look at today's lesson. Can we stop talking? Okay. So we are looking at solving radical equations today. This is kind of fun. We have to solve this equation here and then check for extraneous solutions. So the problem with this equation, if we look at this equation, the problem comes from this x here. We can't get at that x because it's inside the square root. If we wanted to solve this, wanted to factor or do anything with this one, this x is the bit that's causing us the problem. We have to get at that somehow. So in order to get at that, we need to make the square root disappear. We need to make the square root disappear. How can we make the square root disappear? We can square. So we could square this. You have to be a little bit smart. If we were to square this, the only thing we could do at this point is we could square like this. That's going to give us 4 plus 4 root x plus 10 plus x plus 10 is equal to x squared. So if we were to square at this particular point, we're going to do it. So make sure you're good with your quadratic expansions. I'm going to be using the quadratic expansion rule a bit today. That's a plus or minus b squared is equal to a squared plus 2 plus or minus 2ab plus b squared. So using this quadratic expansion rule, what I just did is write that up. This is a squared 2ab b squared.
Sir, why don't you just do minus 2 and then square it like that?
That's what I'm doing. Oh, thanks for spoiling my lesson. Any more spoilers?
Yeah, iron glass.
Who?
Iron glass in the endgame.
No. All right. So this isn't a good path forward because we've made it more complicated and we still haven't got rid of the square root. So what you need to do is you need to rearrange this so you have one square root entirely on one side. Oh, we can do that by rearranging the equation to be root x plus 10 is equal to x minus 2. So this direction isn't really helpful. But if we go to this point and square both sides now, squaring both sides, we get this. That's going to give us x plus 10 there, nice and easy. And here on this side, we'll get x squared minus 4x plus 4. Need to rearrange to solve at this point by factoring. So we want x squared minus 5x minus 6. Have a go at factoring that in your head now. Have a go at factoring in your head silently, so that other people may factor it. Hassan, wake yourself up, have a go at factoring in your head. You should be able to do this type of one in your head, and we've got x minus 6, x plus 1. So at that particular point, what are the two solutions?
X equals 6 and x equals -1.
X equals 6 and x equals -1. Now, the problem comes at this particular point. So if we take an equation such as x squared is equal to 16, we know that if we square root both sides, we have to consider both plus and minus the square root. An extra solution gets added. When we square root both sides, an extra solution gets added, and we end up with two solutions. So here we're doing the opposite of that operation. We're not square rooting, so we're not adding it, considering two possible solutions. We can actually add a solution that isn't real. So here at this point, when we square both sides, the operation of squaring, producing this equation here, in this step, an extra solution appears. Clean this up. So at this point, an extra solution, can appear. Sometimes it doesn't. Sometimes you don't create one. Sometimes both solutions are good. Sometimes you've made one, you have to get rid of it. Sometimes you only come up with one answer. With this one, we've come up with an extra solution. So what you have to do whenever you square both sides of an equation, you must check your solutions in the original equation. So you must go back up to the original equation, this point. So this is the equation that we're trying to solve. These solutions have to make that equation balance for them to be good. If not, then they are extraneous solutions. Sorry, I'm just gonna, give me a second, let me pause this. Okay, so what we need to do at this point is we need to look at the left, we can do a little left-hand side to right-hand side proof. So the left-hand side is equal to 2 plus the square root of x, sorry, let me scroll up, x plus 10. That is equal to 2 plus the root of 6 plus 10, which is equal to 2 plus 4, which equals 6, which is equal to x, which is equal to the right-hand side. Good. This solution is good. We've got 2 plus x plus 10, which equals 2 plus minus 1 plus 10, which is 9. So we've got 2 plus 3, which is 5, which is not equal to minus 1, which is x. X equals 6 is the only solution. X equal to minus 1 is extraneous. This solution doesn't work. Let's have a look graphically at why it doesn't work. Exactly. So here is the original equation. We can rearrange it like this, and at this point we still haven't messed with the equation. We haven't introduced the false solution here at this point. If we graph this, we can see x, root of x plus 10 is going to look something like this. It's going to go from minus 10 there. X minus 2 is going to look something like this. It's going to go from minus 2 here. This is y is equal to x minus 2. This is y is equal to root x plus 10. They're going to cross here at this point at 6. So they're not going to cross here at minus 1. They're not going to cross, so we can see that this isn't a real solution to the equation.
So where do you get the minus 1 from? Like how?
By squaring both sides.
Where does it go wrong?
You square both sides.
So does it have any significance as an extraneous solution?
It's extraneous. It's not a correct
So
solution.
it's
So it is a solution. So x equals minus 1 is a solution to everything from this point onwards. From this point onwards, it will solve all of these equations. It just won't solve that original equation.
What is the extraneous solution?
It means like a false solution. A false solution. A solution comes from the algebra, which is not a true solution to the equation. With more complicated equation solving, you should always check your equation in the original solution, in the solution in the original equation, to see if it is actually a solution.
You put minus 1 into the root of x plus 10 equals x minus 2, you get secant of minus 3. Does that mean anything? It's 9.
Yeah, so from this point onwards, when I square both sides, the minus 1 will work. It won't work for anything in the solution up above that. So I can rearrange the equation as many times as I want. So here at this point, it won't work for this plot at this point. Let me remove that now. So it won't work. It won't work here and here, but when I square both sides, it will work. Because there you'll get -1 plus 10 giving 9. Square root of 9 is 3. 3 squared is 9. Here you'll get -1 which is -3. And then squaring -3, you'll get 9. It's the squaring. So this one, we're putting the -1 in here. Here we've got 3 inside the bracket, and here we've got -3 inside the bracket. Now, 3 and -3 are not the same, but 3 squared and -3 squared are the same, and that's what's causing it. That's what causes it. It won't always cause it. It won't always cause it. Okay, have a go at this one for yourself. Okay, let me show you what we're doing here. So the first thing we want to do is we want to replace this to x plus 6, the radical, and radical 2x minus 4 is equal to 0. Now, a common mistake that I might see sometimes, not so much this afternoon, is at this point, you can, if you were to square both sides at this point, you'd be squaring like that. And there's often a misconception that you can square like this. There's often a this is a very common misconception that I see. And this is not true. You cannot square like this. Mathematics doesn't let you do that. You can't just pick a term. I think the worst one I saw was one term got squared. I'll take out that square root by squaring it. So I'm like, what? What? Okay, that's not possible. So if you were to square at this point, you would get x plus 6 minus 2 root x plus 6 root 2x minus 4 minus 2x plus 4. You've got to open up that bracket and get to 0. So if you square at that point, you're going to get this. And we don't want this. This would be unhelpful. So what you need to do before you do that is to rearrange to root x plus 6 is equal to 2 root 2x minus 4. Squaring both sides, we get x plus 6, we get 2x minus 4. Rearranging, we get 10 is equal to x. Testing the solution. When it comes to testing to the solution, we could test the solution at this particular point because we haven't squared. So this might be your best point in which to test it. So sticking it in, we get the square root of 10 plus 6, which is the square root of 16, which equals 4. You can arrange your left-hand side, right-hand side like this. So we'll get 2 times, what was the number? 10. We've got 20 minus 4, which is root 16, which also equals 4. We can say here at this point that left-hand side equals the right-hand side. So if you don't want to go from the left-hand side and then work it all the way across until you get to the right-hand side, you can start at one, get to 1 point, start at the other, get to 1 point, say, look, those two are equal. You can structure it like this. And this might suit some of you better. So that means this is a good solution. All right. Have a go at this one. Have a go at this one. Right. So straight off, we can just square both sides. We square the left-hand side, we get 15x plus 10. It means we have to square the other side. We'll get 4x squared. 2 3s are 6, so that's going to be 12x plus 9. rearranging things, we got 4x squared minus 3x minus 1, is that right? Then we can factor this, so we've got 4x squared minus 4x plus x minus 1, looks like it's going to work. We take out the 4x here, we've got 4 bracket x minus 1, and there we have an plus an x minus 1. So that gives us the two solutions, 4x plus 1, x minus 1, and we've got x is equal to minus a quarter, and x is equal to 1. Let's check for extraneous solutions. So first up, let's try x is equal to minus a quarter. The left-hand side. The left-hand side is going to be, what have we got? We've got minus 15 over 4, to which we will add 40 over 4. So that gives us 25 over 4, 5 over 2. I'll do the other side, 5 over 2 is 2.5. So 2.5 is a half, sorry, no. 2.5, so this is 2.5, that's minus a half, plus 3, I want the 3. So 2 bracket minus a quarter would give me minus a half, and that's going to be the right hand side. That one's good. X equals 1, left hand side. We've got the root of 15 plus 10, which equals 5, which equals 2 plus 3, which equals the right hand side. They're both good. Do we have questions there on that one?
So what are
Do we have questions? No questions?
I have a question.
No questions? No?
Do you have to always like do left-hand side, like plug in the numbers like this?
You should always check that it works.
But you have to do it in that format.
No? If you notice last time I did it in a slightly different format. It's not a formal proof, so the format doesn't matter. What matters is that you check it. What matters is that you get rid of false solutions if you have them. Typically, I would look to some kind of a method where you're seeing that the equation balance is arithmetic. There is not a formal proof. It's not a formal proof in any way. So you plugging in the number and seeing it balance is fine. I'm not serious on that. I'm just doing it that way to show off. It's important for you to realize I'm better than you. Hence the purpose of mathematics, as I've explained. All right. Have a go at this one. Can I just point out, practice using Pascal's triangle for the expansion of the right-hand side. Were you successful?
Yes.
Excellent. So first thing we want to do is we wish to cube both sides like this. So when you cube the right hand side, this is not the correct answer. When we cube the right hand side, this is not the correct answer. We can sometimes see this occurring. It should not. On the left hand side, we're going to get x minus 5. Here we need to cube using the expansion of Pascal's triangle. Thankfully, we've got a 1 here as the second term, so it's going to make it quite easy for us. We've got x cubed, 3x squared, plus 3x plus 1. Rearranging, we get x cubed plus 3x squared plus 2x plus 6. At this point, we notice a ratio of 1 to 3 here, and the same ratio repeated here. Just enlarged by a factor of 2. We have the same ratio between these. This would indicate that we would quite possibly factor by grouping. So we do an x squared, it gives us an x plus 3. We do a plus 2 there, and we get an x plus 3, and at that point we're like, yes, success. So we've got x squared plus 2, x plus 3 is equal to 0. This gives us, this one has no real solutions. This would give us x squared equals negative 2, which is not a real answer. So this one here gives us x is equal to negative 3.
Wouldn't we need to also solve the complex solution?
No. This one has 2 complex solutions. It would be
Plus minus I root 2.
Let's try this in our original equation. Left-hand side is equal to the cube root of minus 3 minus 5, which is the cube root of minus 8, which is minus 2, which is equal to minus 3 plus 1, which is the right-hand side. Any questions on this one? Okay, so we've got 2 IXLs for homework, and we've got a worksheet to work with. Next class, we start our new unit. We're going to have a real short. Next class, we start our new unit.
There's no major for this unit?
There is a major on around the 17th and 18th on everything we've covered on up to that point. So it will. The next major will start off where we left off. So there'll be some binomial theorem. There'll be all of this unit. There'll be a bit of geometric series and sums. There'll be a bit of exponential functions, and maybe we've got some logarithms in by there, but they just keep cancelling left, right, center.
According to the syllabus, the unit we major was supposed to be on December. So like, yeah, I know, but like if it's that off, like surely some units are gonna be just cut off.
Where are we?
Course calendar. No, like the course syllabus, not the course calendar.
So we are going to have an exam on everything from the semester exam onwards. So everything here on binomial theorem, inverse functions on unit 3. The exam is going to be there, so everything we managed to get to by that point, we'll have in the exam. We've got another test towards the end, but yeah, I can't remember where the last one is. The syllabus. So this unit here, we did unit 2 and 3 as the same thing. So the complex number stuff we did with polynomials. This is unit 4. Next up is logarithms and exponential functions, and then trigonometry. It wasn't up to date at the beginning. You maybe have a rail. Right.